Does this look like your gate?
Yeah, cuz my gate's munted.
Okay, bro, well the best way to fix it is to add a brace. Is your gate timber or steel?
Oh, timber, I'm not a fancy fella like you with your flash steel gates you're making.
Yeah, alright. For a timber gate, do we add a brace like this or like this?
Do I look like an engineer to you, cuz?
Don't worry, it's super simple to learn. I'll show you quickly. This looks good, eh?
Oh, yeah, nah, but I thought that would work because triangles.
You're right, bro. Triangles are strong, but for timber, this is the wrong direction. If you build your timber brace that way, the nails and screws fastening the brace in place will be the only things stopping your gate from sagging.
Probably why my gate's knackered and the nails have all pulled out.
Don't worry, there's a super easy fix for your gate. If you turn the brace around the other way and fit it inside the frame, ta-da, holds on its own. It works even without any fasteners.
Oh, that's spooky.
Look, this little model gate made out of popsicle sticks will even hold a bicky. Or 2. Or 3.
Oh, sweet as, yum. Can I have one?
Maybe, if you answer this correctly. For your wood gate, you put the brace this way. But for my steel gates, the brace goes which way?
The other way?
Yeah, you're right. Have a bicky, but why? Some basic structural engineering theory is needed here. When I was studying building science, this helped me a lot. Grab that sponge, bro. So I've drawn lines around the sponge in a grid to represent stress.
The stress here?
No, stresses that are occurring inside the steel or wood, like the ones that caused your gate to fall apart. If we imagine that piece of foam is a timber beam and it's supported between 2 points represented by your hands, and we imagine there's a load on the beam.
Like another bicky?
Not yet. The load causes the beam to bend a little. The foam is exaggerating it, but when you apply the load to the beam, on top of the beam, the lines get closer together. This is known as compression. On the bottom of the beam, the lines are getting further apart. Now this is known as tension.
Closer, compression, further apart, tension. Okay, but what does that matter, Al?
I'll show you in a minute. It's just important to understand those concepts first. While we're at it, give the foam a twist. Now that's called torsion. That'll come in handy later. Okay, so here's a popsicle stick made out of wood. It's very strong in compression, but not so strong in tension, as we explained earlier. That's why it works so well in this direction on our gate, because the gate is trying to compress it, unlike in your gate, where the ends of the wood have split and the nails have pulled out of the ends because it was in tension.
So why does the steel brace go the other way then?
Because steel, it kind of has the opposite properties to wood. It's not so good in compression. But it is great in tension. And therefore, if we put this thin piece of steel wire in as a brace, the same way that worked for the wood brace,
And load it with bickies.
and load it with bickies,
Oh, it's lame.
yeah, it bends under compression much more easily than wood. But if we flip it around and load it again,
Oh, hey, that skinny little wire holds those bickies, no worries.
bro, steel is super strong in tension, and if we use it that way, we can use less of it.
Oh, timber, squeeze it, steel, stretch it.
Yeah, you could say that. That's why the brace that runs from corner to corner on my timber and my steel gates run in opposite directions.
But why did you put the short ones in going the other way then?
I just like the way they look with a cross.
See? Fancy fella, eh?
Yeah, they do also help a little with resisting the twisting or torsion.
Is that why mine's floppy?
I reckon it is. Twisting is not as much of an issue for my steel gate as the welds are really strong, but for a timber gate like yours, the best way to resist the twisting is to fix a sheet or panel of something like plywood to the gate, or by fixing a bunch of pickets to the gate.
Choice. So to fix my gate, put the brace in the right way so it's being squeezed, and put the pickets back on.
Yeah, bro. Put a couple of nails into each end of your fence pickets. Maybe even add some nails where they pass the brace. That should sort it.
Oh, sure, thanks heaps, Daz. You cuzzies all better subscribe to Kiwi Daz, eh? I'm gonna gap it and go fix my gate before I forget what to do.
And eat all my bickies. Later, bro. I better get back to making my gates too.
Here I am using a clever little hack with some magnets, pinning some fishing line crossing from corner to corner to see if my gate frames are perfectly flat and in plane. Check out my previous video on how to weld perfectly square gate frames, where I welded up these steel gate frames using my super awesome right angle welding jig. I've also got another video on how to build the 90-degree welding jig. I'll throw some links in the description and a pinned comment to those videos. The frames are incredibly close, but since I'm a fancy fella, here I am clamping the frames to my deck railing and tweaking them to get them perfectly flat. I've drilled holes in the corner of the gate frames where the cross braces will attach. Here I am drilling holes in the middle of the cross braces where the other cross braces will attach. I'm drilling all the holes so that the internal surfaces of the steel tubing will all be connected, so that when the gates are finished, I can pour some primer and fish oil in to protect them. It's probably not making a lot of sense right now. I'll cover this in more detail in a future video. It's much easier to drill through steel using a drill press as I am here, as drilling through steel requires a slow speed and good even pressure. I'm also using some cutting fluid to keep my drill bits cool, which helps to keep them sharp. I'm working up in sizes from 2 to 4 to 6 to 8 millimeters. You can also use a stepped drill bit, which are great for this purpose. Time to weld in the cross braces. I use some handy clamping pliers to hold them in place while I tack them on with my MIG welder. Because I drew up the gates on my computer and had accurate measurements for cutting my steel, all of the pieces are fitting really easily, with just a few touches with a grinder here and there to get them to fit perfectly. Once I've got these shorter braces clamped in place, I then just tap them with my hammer to get them aligned, eyeballing them just to make sure that they're perfect before I finally tack them in place. My MIG welder is pretty basic and only has a very short hose on the gun. This means quite a lot of repositioning to get all these welds done. Once the braces are tacked in place, I remove the clamps and start welding them off completely. This takes quite a while as there are a lot of joints and facets to all the joints to weld. Here you can see that I am just welding in spots, not just squeezing the trigger and going as fast as I can. There's a couple of reasons for this. One, there are some slight gaps in the joint in places, and by slowly filling in the weld area, I am less likely to just blow a hole through. And two, if you put in a bunch of weld all at once and heat up the metal, this can cause the steel to warp. To reduce the risk of warping, it's also good to be methodical about how you weld and evenly work your way, welding opposite sides in close succession. I'm working around the frame, going from joint to work on different areas rather than completing all of the faces of one joint at once. This helps by allowing each joint time to cool before I return to weld another section of that joint. On the internal corners, I am layering in quite a bit of weld so that when I grind it back later with the die grinder, there is enough weld to contact the radius of my die grinder bit. With one gate all welded off, now I'm working on the second gate. Rinse and repeat. I hope you're enjoying the music that is all original Kiwi Daz tunes that I craft specifically for these videos. Oh my god, seriously, how cool is welding? I only learnt how to weld a few years ago in my 40s and I'm really enjoying it. I've been making things my whole life with wood and I love tinkering and fixing things. I'll be honest, I was a little terrified when I purchased the welder and all the gear to do my first project, but after a friend gave me some initial guidance and got me past the fear of electrocuting myself, I've been enjoying it ever since. It's a completely different experience to working with wood. I had tried welding a long time ago and really struggled when I needed to fix a tractor implement with a very old stick welder and basic helmet. Both the MIG welder and the auto darkening helmet, for me, made the learning experience a much more enjoyable experience. You're not jumping out of your skin every time the weld starts and it's much easier to relax and see what you are doing. I initially bought the welder to make a guard railing for my stairs, as I had worked out that I could buy all of the equipment and steel for a fraction of the cost that I was quoted for that one project. Now I'm finding more and more uses for it, like these gates, that I could have made out of wood, but the steel is much more suitable for these big gates. I'm maybe enjoying it a little too much. I noticed the weld was looking porous, and then I checked the gauges on my bottle of shielding gas, and unfortunately it's empty. There is a saying, the grinder makes me the welder I ain't. I was encouraged to buy a MIG welder as it's the easiest way to learn, and apparently you can get so good at it that you don't need to bother grinding your welds, as you can make your welds so neat that they are part of the finished product. Maybe I'm too much of a fancy fella, but I think it will be quite a while before my welds look that good. I ground a recess into all of my joints before I welded them so that I could grind them back flush and they would still be strong joints. Grinding does take a reasonable amount of time, especially the die grinder, which is the tool I am using to grind the welds from the internal joints. The die grinder also sprays fine particles of steel everywhere, which is not the most fun. When you are designing up a project, it is wise to factor this in and, where possible, minimize the amount of this you need to do. Thanks for tuning in. If you made it this far, I reckon you should subscribe and leave me a comment. In the next video in this series, I'm going to be adding some tabs for fixing timber to the gates, and then they'll be ready to go to the powder coater. Thanks for watching. Later, Al.